3.9 talks about antiderivatives, so that's working backwards from a derivative. So if I take a function f of x and I want to take a derivative, well, we know that's 2x. A derivative of part b is 2x plus 0. Well, that's 2x. And a derivative of part c is also 2x minus 0, which is 2x. So this is called differentiation. Antiderivative is working backwards. That is, if I told you f prime of x equals 2x, well, from the previous a, b, and c, you should know, that f of x, what we took the derivative of, must have been x squared, but you wouldn't know whether it was x squared plus 200, x squared minus 1000, or just x squared. So to play it safe, you say, you know what, there could have been a constant. The constant could have been 0, it could have been 200, it could have been negative 1000. But if I was to take a derivative of that, that will be 2x, and the derivative of the constant will be 0. So here we're going to separate in the beginning the difference between a derivative and an antiderivative. We're going to say the derivative is the lowercase in the beginning, and an antiderivative is the capital. So we say f of x is x squared plus c, and little f of x will stand for the derivative. If you're not liking that, just stick with f and its derivative. That works as well. The most general antiderivative of f is normally f of x plus this constant c, as you saw in the previous example. And here's the most common we're going to start with. If I take a derivative of a power function, what a power function is, a variable raised to a number. As long as that number is not a negative 1, I will add 1 to the power, divide by that. So basically, remember, if I take a derivative, if f of x, recall, if f of x is a power function, then the derivative, bring the power down, subtract 1 from the power. To undo that, you would add 1 to the power and divide by that new power. So, if I'm looking at this problem, no need to guess anymore. Here I said you could look at the first 3 examples, but if I wanted to figure out, if you told me that f of x or f prime of x is 2x, if I want to find f of x, I will take 2, I will add 1 to the power, well, 1 plus 1 is 2, and I'll divide by that plus c. And as you notice, you will get that without looking at a, b, or c. So, if I want to find the most general antiderivative, the book uses capital letter in the beginning. Capital letter is antiderivative, and the derivative is lowercase. Again, you could stick with f of x and f prime of x if you wish. I really don't mind, but the book does that. So if I take this piece, if I add 1 to the power, because that's a power function, that is a 3, divide by it. Add 1 to the power, that becomes a 2, divide by it. Now, 3x, you have a couple of options. What do you take a derivative of to get a constant? Well, derivative of, if f of x is ax, then the derivative is a. For you to have a derivative being a constant, that means you must have taken a derivative of 3x, or you could view that as, if you like, you could view that as f of x is x to the 0, add 1 to the power, so 0 plus 1 is 1 over 1, if you like. Or simply, what do you take a derivative of to get a constant? Well, it has to be the constant times x, and we'll add c. So capital F of x is x cubed over 3 plus x squared plus 3 plus c. I can take a derivative of my answer, and I should get this. Part B, if I want to find capital F of x, add 1 to the power, divide by that. add 1 to the power, divide by that, add 1 to the power, divide by that, add 1 to the power, divide by that, plus x plus c. Or I could simply say f of x is x to the fifth minus 3x to the fourth over 2 plus x cubed over 3 minus x squared plus x plus c, and there it is. Do remember that a derivative of sine is cosine, but we're working backwards. And a derivative of cosine, oops, I messed up, is negative the sine. So when I want to work backwards, I will say that's a plus, that's a minus. When I say, what did you take a derivative of to get sine? It has to be negative cosine. Similarly here, and similarly here. So keep that in mind. Again, it takes a while to get used to. Capital F of x would be add 1 to the power, divide by that. What do you take a derivative of to get cosine? You take a derivative of sine to get cosine. And I'm going to write this as x to the 1/2. Add 1 to the power. 1/2 plus 1 is 3/2. Divide by that. Plus c. So I'm going to say what I took a derivative of must have been x squared over 2 plus 3 the sine of x plus 2/3 the square root of x cubed plus c. Of course, you could leave your answer like that out of mind. That is the same thing. And if I tackle the next problem again, capital F of x, which is the antiderivative, that would be, well, I'm going to rewrite this. You know what? Let me rewrite it first. So I'm going to rewrite f of x as 3. Isn't that x to the negative 2? So capital F of x would be 3. Add 1 to the power. Divide by that. What do you take a derivative of to get secant squared? Well, that must have been tangent. Add 1 to the power. Divide by that. That must have been an x plus c. So if I simplify this a bit, I'm looking at f of x equaling, you know what? I'm going to go underneath it. I'm going to say f of x equal negative 3 over x minus 5 tan of x plus x cubed minus x plus c. And there it is. Now, to find c, they give us initial conditions. Find the antiderivative of the function. Well, to start with, we say f of x is add 1 to the power, divide by that, add 1 to the power, divide by that, plus c. That would be the answer, except if they gave us initial conditions, this is a point on the graph of capital F. When x equals 0, y equals 3. 3 equals 0 plus 0 plus c. So that tells me that c is 3. So my function is x cubed over 3 plus x squared over 2 plus 3. This is a function in which the derivative will equal that and f of 0 equals 3. So this is called an initial value problem because they give you initial conditions to find what c is. Similarly, if I find capital F of x, add 1 to the power, divide by that. What do you take a derivative of to get sine? Remember, that's negative cosine of x plus c. So capital F of x is actually x to the 6 over 6 minus twice the cosine of x plus c. I would have been done right here, except they gave me this initial condition. So I'll say f of 0 equals 5, y equals 5 when x equals 0. That's a 0. If I put a 0 there, that cosine of 0 is 1. That's 0 minus 2 plus 0 plus c. So c would be a 7. So f of x would be x to the 6 over 6 minus twice the cosine of x plus 7. That would be a function that satisfies the derivative is right there and f of 0 equals 5, the initial condition. Couple more to go. If they gave me two derivatives, well, I will say the first derivative will be add 1 to the power, divide by that, add 1 to the power, divide by that, add 1 to the power, divide by that, plus x plus c. And to find another antiderivative, I'll say the initial must have been add 1 to the power. When you divide by 5, 4 times 5 is 20. Add 1 to the power. 3 times 4 is 12. Add 1 to the power. 2 times 3 is 6. Add 1 to the power. Now, you must have had a c times x and a new constant. Every time you take an antiderivative, you must pick the extra constant that could have been there. This is x to the 4th over 6 minus x cubed over 2 plus x squared over 2 plus cx plus d. And you could check by taking two derivatives of this, and you should get that function right there. And what if I took three derivatives? Well, it's the same. It doesn't really matter. I could write this as x to the 1/3. So you must have taken a derivative of, and we undo this one derivative at a time, add 1 to the power, divide by that. What do you take a derivative of to get sine negative cosine of x plus c? So f double prime is actually 3/4 x to the 4/3 minus 5 the cosine of x plus c. Undoing a derivative again, 3/4, add 1 to the power, that's 7/3, divide by that, that's 3/4, minus 5, what do you take a derivative of to get cosine? The sine of x plus cx plus d. A bit more space. And to figure out what f of x is, so this is 9/16, add 1 to the power, that is 10/3, divided by 3 over, just let me check. Yeah, I messed up there. That should have been 3/7. You guys didn't say anything. Right? Add 1 to the power, divide by the new power. So that's 9/28. Add 1, 3/10, minus 5. What do you take a derivative of to get sine negative the cosine of x, plus c, add 1 to the power, divide by that, plus dx plus e. So every time I take an antiderivative, when I take three antiderivative, I should know I'm going to have three constants to deal with. So I could say this function is 27/280 x to the 10/3 plus 5 the cosine of x plus cx squared over 2 plus dx plus e. Again, kind of long, not that hard. And what if they gave me initial conditions? That means I could figure out what those variables are. So if I go by the first problem, now the first problem needs a bit of manipulation. I'm going to say f prime of x is actually, I'm going to split those, x over x plus radical x over x. So f prime of x is 1 plus x to the negative 1/2. Well, f of x, x plus add 1 to the power, divide by that. So f of x is x plus twice radical x plus c. I would have been done right there, except they gave me initial conditions. They say when x equal 1, y equal 2, so 2 equal 1 plus 2 plus c. So c equal -1. So just replace that by -1 and you're done. So f of x is x plus twice radical x minus 1, and there it is. That's a function that satisfies these conditions. Here I have to undo two of those. Well, let's start with the first one. The derivative of x, add 1 to the power, divide by that, minus 4x plus c. Now I could find it right here because it says the derivative. It says in the derivative, when x equal 1, the derivative is -4, so -4 equal 1/4 minus 4 plus c. Those cancel out. So c is negative 1/4. So that means f prime of x is actually x to the 4 over 4 minus 4x minus 1/4. Now I'm going to have to do that one more time. If I take another antiderivative, that must have been add 1 to the power. 4 times 5 is 20. If I add 1 to the power, that's x squared over 2. That means you divide 4 2 times, minus 1/4 x plus, you could call it c if you want, you could call it c2, you could call it d, whatever you like. But they gave me also a point on f. They said when x equals 0, so that would have been my answer have they not given me the initial condition. F of 0, we'll put 0 in for x, and that should equal a 3. So that means d equals 3. That means the function that satisfies all of these cases combined is the following. This is a function in which f of 0 equals 4, f of 0 equals 3, and the derivative at 1 equals negative 4. And that's pretty much it for this section.